All right, I want to start with a little trig review. We don't need an enormous amount of trig for this course, but we need basic triangle trig. And we're going to focus on using it with vectors a lot. So we'll talk about that too. Now let's start with the idea of a right triangle and define what we have. We know that there are 180 degrees in any triangle, and that means the sum of the measure of all three angles of a triangle is 180 degrees. That's what I mean by 180 degrees in any triangle. For a right triangle, we know that one of those is 90 degrees. And that means that the remaining angles also have to add to 90 degrees. And these two angles are called complementary. That's where the co in cosine comes from. It's a complementary angle relationship. So what do we know about right triangles? Let's talk about the language. The longest side, the one opposite the 90-degree angle, is called a hypotenuse. And the other sides are called legs. All right. What do I want to say about this in relationship to vectors? The hypotenuse is always the total vector magnitude. And the legs are the components. In particular, perpendicular components, because we choose our coordinate systems that way. All right, so there's a little bit of language. Now we're going to use some new language. We're going to define this angle theta in this right triangle. And now we're going to talk about the sides in relation to theta. So we're all used to seeing our sides called A, B, and C if we've ever done anything with the Pythagorean theorem. That tends to be the way they're labeled. So the longest side, we're still going to call the hypotenuse. The side opposite angle theta, we're going to refer to as the opposite side. And A then would be the side adjacent to angle theta, right? Next to or across from. So when we talk about our trig functions, this is the language we're going to use because we're talking about it in relationship to that angle. So again, we mentioned the Pythagorean theorem. We know that the hypotenuse squared is equal to the measure of the legs squared and added together as well, right? The lengths. And we often see this just written as a squared plus b squared equals c squared. So if we want to talk about the magnitude of a vector, that would be the components squared and then take the square root because the components form a right triangle. All right, we're finally ready to actually define our trig functions. There is a silly mnemonic for this. SOHCAHTOA, just nonsense, but it helps you remember. This stands for sine is equal to the opposite over hypotenuse. So sine theta is equal to the opposite side over the hypotenuse. Cosine theta is equal to the adjacent side over the hypotenuse. And tangent theta is equal to the opposite side over the adjacent side. Just wrote that wrong. All right, so let's draw our triangle and talk about this. I'm going to call this one theta, just so we don't get used to doing it the same way all the time. So now this is my adjacent side, and this is my opposite side. Let's call them something. I'm going to call my hypotenuse V. My adjacent side, I'm going to call VY because it's my horizontal or my vertical component. My opposite side, I'm going to call VX because that's my horizontal component. So if I were to look at the sine of theta, that would be the opposite over the hypotenuse. So sine theta would be equal to VX over V. Cosine theta would be equal to the adjacent side over the hypotenuse, so VY over V. And tangent theta would be opposite over adjacent, which would be VX over VY. Oops, or XX, VX over VY. And these are more opposite of what you would have learned in a basic trig class because I've drawn my angle to the vertical component here instead of to the horizontal component. So what happens if we draw to the horizontal component? So I'm just going to call this phi. Now, if we were to look at sine of phi, that would be the opposite over the hypotenuse, which is now Vy over V. And cosine phi would be the adjacent over the hypotenuse, which is now Vx. I'm going to subscript these with a theta because those are referring to the theta angle. So the cosine of phi is the adjacent over the hypotenuse, which is Vx over V. And these are what you would have learned in your basic trig class because you're all told to always draw your angle to the x-axis. And finally, tangent phi be Vy over Vx. All right, so our choice of angle determines how we describe the adjacent and the opposite. So what do I want to talk about here? We said earlier that the angles opposite our legs are complementary angles and they add to 90 degrees. So now let's look at sine theta and cosine phi. Sine theta and cosine phi are the same thing. Sine phi and cosine theta are the same thing. That's what complementary angles are. The sine of an angle is equal to the cosine of its complement, and vice versa. So the last relationship I'd like to talk about before we finish here is tangent theta is equal to sine theta over cosine theta for any angle. And this comes again directly from our relationship looking at our triangle. If we were to take, my thetas have scrolled off the screen, but if you were to take sine theta, which we said was Vx over V, and cosine theta, which is Vy over V, you can see that you can just multiply by V over V and get the relationship for tangent theta. So that's a straightforward one. From the Pythagorean theorem, we know that sine squared theta plus cosine squared theta is equal to 1. And as far as an introductory physics class goes, this should be as much trig as you're probably going to use. This comes in useful solving systems of equations sometimes, so does this. More functional identities. You're probably not going to use for this course unless you run into a specifically hard setup, you know. But for now, that's enough trig.